Right, hello. Here are your atomic models that you've been making this week. I'll give you a closer look at them in a minute. There's some really interesting designs. And look how different they are. What have they got to explain, these models? Well, remember, we've got changes of state. We've got substances like water, which can be really hard. So hard that if you fall on it, you can hurt yourself. Ice. But the same substance, when given more energy, flows freely in rivers, in a glass of water. When given more energy, when heated, the particles seem to separate from each other and become invisible. This air has many water particles in it, but we can't see them. Changes of state. All substances show us changes of state. They can be solid, liquid, or gas. What else do the models have to try to explain? We've got chemical reactions. When two particles come together, sometimes they react in some way to produce, sometimes, a substance which is entirely different. For example, when atoms of hydrogen, normally a gas, and atoms of oxygen, another gas, come together with enough energy, they stay together to form an entirely new substance, water. So there's chemical reactions. What else? Do you remember the dissolving? I had this huge cylinder, full, completely full of water, but we found we could dissolve in it loads and loads, spoonfuls of salt, without it overflowing. How do the particle models help us to decide what was going on there? And recently we've been talking about electricity, and we've learned that part of the atom must have a positive charge and part of it must have a negative charge. So there must be two distinct parts to the atom, whatever it looks like. Let's give you a closer look.